everyone, welcome back to another episode of the Confident Chemistry Teacher podcast. Today I'm just going to be talking about what I do in my electrons unit. And of course my electrons unit comes after the atoms unit. And from that atoms unit, I wanted to mention, I know I was going to tell you a little bit more about my isotope and marshmallow lab. I haven't had a chance to do it yet with my students this year, so I'll record an episode on how I handle that because I wanted to make some tweaks and then share those tweaks with you. So in the next episode or two, you should expect that one. I'm sorry, it might not be useful for this year, but you could always save that episode and then use it for isotopes and average atomic mass for next year. So that lab episode is coming. But today we're going to be talking about electrons. So the three main topics that I have in my electrons unit is the history of the atomic model and how it's changed over time. I mentioned in the last unit, the atoms unit, that I don't actually talk about atomic history in that unit because I really just want the kids to focus and learn about what a proton, neutron, electron is, how to calculate it. They're already doing average atomic mass calculations, which is hard for them. And so they don't really know like the different parts of the atom yet in that chapter, so that's why I include it here. And so by now they know all those things about, the structure of the atom, and then now we can talk about how it's changed over time. So I do discuss that. I have a really great activity that I bought from, why do I always get stuck on this? She makes AP chemistry videos on YouTube. I think it's like Mrs. Raz. I got it off of TPT. It's like a little card sort of activity. It has pictures and stuff like that. I really like that. In years past, I've also just shown like simple crash course videos, and that's been like sufficient depending on the group of kids that I have. So I do start my electrons unit off with like the development of the atomic model. The next thing that I teach in my electron unit is I actually do the light equations. So like C equals wavelength, sorry, I haven't taught it yet. It's been a while. Okay, so C equals wavelength times frequency equations, and then the E equals H times V equations. So I teach that now first. I've kind of gone back and forth in my many years of teaching chemistry. Do I teach electron configurations first? Do I do light calculations first? I like to start off with the light calculations because I use the fireworks as an example, like of my anchoring phenomenon for this unit about why do they produce different colors of light. And so I think that ties in nicely with this chapter. And then I do the light calculations at the beginning. That way the kids can have more practice as the unit goes. I think I mentioned that my kids struggle with the math part. So if I do it at the beginning, if they need to retake a quiz, there's still plenty of time to learn that content or relearn it or re-quiz on it before we actually take that test. So if the light half of my chapter is I'll do Google Slides. And I hate to make a shameless plug here, but I do have a pretty good Google slideshow in TPT if you're interested. It has lots of practice calculations there. I'll do like a practice calculation worksheet that goes along with that. And just as a reminder, if you haven't yet gotten yourself a set of classroom calculators, this is definitely the time to do it, especially because you're using the scientific notation values and just entering them into the calculator. If you can show your class on the same calculator, that is super awesome. And if you don't have a class set of calculators, put it on your wish list for next year because it really does make teaching this unit easier. After I do the Google Slides and some practice worksheets, I'll do the POGL. The POGL that I like for this one is called Electron Energy and Light. They get into their POGL groups. They're really discussing this idea about how electrons are promoted to the excited state, about how they fall back down to the ground state, and about how they release energy. And in this POGL, it does a nice job of showing the different wavelengths of the different color of light. Because we all know, like, there's those questions, which color has the longest wavelength of light? And, of course it's red. Which one has the shortest wavelength of light? And we all say violet, but I feel like those pop up on a lot of multiple choice questions. So I feel like that's like another good review about those wavelengths and those colors. The next thing I do is the flame test. And so if you're not familiar with the flame test, I basically take coffee stirrers, like little wooden sticks, and I soak them overnight in solutions. I want to say I feel like they're chlorides I normally do, like sodium chloride, strontium chloride. Like, so it's just a bunch of different like metal chlorides that we have. And then the kids can go ahead and pass them through the Bunsen burner flame, and they should see the color of the flame change over time. Kids really like that lab because they do get to see these different colors. Then I like this lab because I usually have them do calculations on it, and depending on the class, calculate the frequency of light, and then they use that frequency to calculate the energy of the photons that are emitted there. Now, something else that I definitely want to do this year is the spectroscope lab. So this idea about where you take gas tubes, you have like little plastic spectroscopes. I've done this too with like little diffraction. I guess like they're like diffraction slides if you're old enough to know like what a slide looks like, not like a Google slide, not like a biology slide, but like something that you would put in like a slide projector. And so you could use those as well to see these different wavelengths of light, or at least these different colors of light. And so I have a little PowerPoint that I walk the kids through as we're doing this. They can look at the light, they can look at the spectroscope, or the atomic emission spectra, let me say that, on the Google slideshow, and then they can go back and forth. And while the plastic cheap spectroscopes, I think they're like $15 from Flynn, aren't perfect, they do get to see like, they get to see the different wavelengths of light. And then I forgot to mention, because it's at the bottom of my list, there are 2 good TED Ed videos that I like to introduce this topic. One is called just What is Light? And then How Do We See Color? So it's just nice to break up your instruction with a couple of videos. So like I said, those are TED Ed videos, What is Light and How Do We See Color? So that's basically how I run my light side of my unit. Then for electron configurations, of course, I start off with Google Slides. I told you guys I'm kind of a traditional teacher in that way. And in fact, I made a set of Google Slides that I have not posted on TPT yet because I haven't been able to do it yet, but I'll post it for you guys if you're interested. I always kind of joke, I always kind of try to run my PowerPoints through with my kids first, my students, and I joke I give them a piece of candy every time they find a typo. So just so you know, I'm going to share these with you, but they have not been, what do I want to call it, kid reviewed yet. So there might be a few typos in there, but check out that Google slideshow if you don't have anything that might be helpful for you. I do the electron configuration POGL for this one. This POGL is really good. I like that it mentions Aufbau's principle, Hund's rule, and the Pauli exclusion principle in there. And then it gives us some good analogies that we can refer back to when we're trying to talk about those 3 principles. I also used to show this really great animation. I think it was from like the University of Arizona, but it was like JavaScript. And then when Java didn't work on computers, again, sorry, I know this is really old, it didn't work anymore, this animation. And I haven't found an animation as much as I like for that. So I'm kind of putting a call out there. If you guys have like a really good, and let me say, this animation was an orbital filling diagram animation. And the reason that I liked it is as it would fill in the electrons, it would tell you what the element is. And I've seen some others that do that. But as you would start to put the electrons into the 3D orbital, the 3D orbital would drop, and the kids could see then how once the 3D orbital was filled, it was technically at a lower energy level than the 4s orbital was. And so then that's why when electrons do leave, they leave the 4s orbital before leaving the 3D, because the 3D is at that lower energy. I hope that makes sense. But if you guys have an animation that does that out there, I would love to know about it, because right now I'm kind of just drawing it on the board. I've thought about maybe making like laminated things. I might do that this year that like are magnetic that I can just move on the board. I don't know. I've got some ideas going around. Then I have to tell you, I was brought up using the old orbital filling diagram that starts off with like 1s2, then right underneath it, it says 2s2, and then it says 2p6 next to it. So I hope you guys know what I'm talking about. It's kind of like a diamond shaped thing, but I also now teach the kids, because I got the idea, or I saw another teacher doing it, is how to do the electron configurations with the periodic table. Groups 1 and 2 being the S, the transition metals being the D, basically groups 13 through 18 being the P, and then the lanthanides and actinides being the F orbitals. So I also show my kids how to count that way. And then it makes it easier to recognize, actually, if your element ended in 3p, you can just go to that to group 13, 14, 15, to group 15, and then just slide down and count down how many rows there are. So I show my kids that as well. And then we do some like whiteboarding activities, some challenges. Now, some stuff that I don't teach that I used to teach in this chapter are quantum numbers. I think I've mentioned before I had a tremendous mentor who really helped me out when I was first starting to teach chemistry, and he totally taught quantum numbers. But again, this was before COVID. And now that quantum numbers aren't even on the AP exam, I really don't teach those unless I have like a super kid who's interested, maybe like an early finisher for honors. You know, some of those kids are just whipping out those worksheets so fast. So I might give them the worksheet that I have on orbital numbers. It's like a little puzzle that they have to figure out. So I really don't teach the quantum numbers to my students anymore in this electron unit. So I'm sorry if that kind of was just like a list of things that I do, but I like to hear how other teachers are teaching their unit. So if you're doing something different in your class, then let me know. I didn't mention every single thing I did, just like the things that are like my highlights. I'd love to know what you're doing in your classes, so please share. And so just as a review, I start off with the history of the atomic model. That leads me into my light and energy calculations, and then we move on over into electron configurations. The next inside the unit that I'm going to be doing is for periodic table properties. So for me, for those periodic table properties, I usually just do atomic radius, ionization energy, and electronegativity. Depending on the class, I'll sneak in ion size and electron affinity. So you guys, as always, please keep experimenting, keep inspiring, and keep making your chemistry classrooms awesome. Happy teaching.